Hello people, welcome one and all to Jojo's Learning Club.
Hello guys, I'm back again with another video on simple equations, and in this video I'll be doing work problems on simple equations where you'll get better understanding on simple equations. So let's directly go and start with the first problem. So whenever you have a problem, first you have to analyze and read the question very much carefully before doing the problem. So first let's read the question. A copper wire has a length L of 1.5 kilometers. So from this question, when you have a question, you have to write all the given conditions, then it would be easy to find the solution. So from this given solutions are L is equal to 1.5 kilometer. Okay, so next, and the resistance are of 5 ohm. So resistance is set as 5 ohm. Okay, and next, and the resistivity of, so resistivity is given as 17.2 into 10 raised to minus 6 ohm millimeter. Okay, so now let's what is the next condition? Find the cross sectional area of the wire. So we need to find the A is not given, and we have to find the cross sectional area of the wire. Given that R is equal to rho L by A. So from that we know that R is equal to rho L by A. Find the value of A. For that, first do the cross multiplication, then you will know that A is equal to rho L by R. Okay? And we know all these values, but check the value of kilometer. It is given in terms of kilometer, right? But we need to find in terms of millimeter. So first we have to convert this 1.5 kilometer in terms of millimeter. So we know that 1 kilometer is how much? 1000 meter, and 1 meter is 1000. 1 kilometer you can express as 1000 into 1000, that is 10 raised to 6 millimeter. So how you would be expressing the value of L over here as 1.5 into 10 raised to 6 millimeter. Similarly, so let's write, so what is the resistivity given? 17.2 into 10 raised to minus 6 ohm. So we are not considering the units over here. So but please be careful with the units. So while doing calculation, I'm not taking any units. So 17.2 into 10 raised to minus 6 into 1.5 into 10 raised to 6 by 5. Right? So what is the value over here? 10 raised to 6 and 10 raised to 6 both gets cancelled. Okay. And another one thing is that, so 17.2 into 1.5, so rho into L by A, right? So rho into L by A, so it is nothing but 5, which you can write 15, that you can write just 0.3, right? So now I'm going to do the same. 172 into 3, what is it? 6, 7, 7 3s are 21, so 5.16. So I got the value, sorry, 516 is the value I got. But how many numbers are there after the decimal point? Here 1 point, and here also 1 point. So you have to put a decimal point here. Alright. So what's the final answer? 5.116 millimeter square. So that's the answer for your first question, and this is how you find answers from a linear equation. And now let's find the problem answer for the second problem. So the temperature coefficient of resistance alpha may be calculated from the formula RT is equal to R0 into 1 plus alpha T. So find alpha. So we need to find the temperature coefficient of resistance, that is alpha. Okay, so what are the given conditions? It's already said. Find alpha if RT is equal to 0.928, 0.8 and T is equal to 40 seconds. So we need to find the value of coefficient of resistance. So for that, first let's simplify the formula. RT is equal to R0 into 1 plus alpha T, right? So what is the value? So we need to find alpha from it. RT is already given, so just substitute the values. 0.928 is equal to 0.8 into 1 plus 40 alpha, or alpha 40. It's same as 40 alpha. So 0.928, and now open the brackets. So 0.8 plus 0.8 into 40, what it would be? 4 8s are 32 and 320, so 3.2 alpha. Okay, now take the variables on one side and constants on the other side. So 0.928 minus 0.8, which is same as 0.880, which is equal to 3.2 alpha, and from this you know that 0.128 it is, right, and it's equal to 3.2 alpha. So what is the value of alpha? Alpha is equal to 0.128 by 3.2. As I said, when you have such kind of problems, always try to eliminate the decimal points when you have a division. So what you have to do, you have to multiply here with 1000. So it becomes 128 by, when you divide, it becomes 300, right? 3 points are going to multiply, so it becomes, so you already know the value would be 0.004. So that's all for the problem number B, and now let's do the problem number C. It's easy, right? So when you know all the rest of the quantities, as I have discussed with the symbols of the equation, to find the symbols from the find the subject from the symbol, what you have to do, substitute for all the other symbols and find the subject from your equation. Similarly, so now we can do the problem number C. So first let's read the question. The distance S meter traveled in time t seconds is given by the formula S is equal to ut plus half at square. So where u is the initial velocity in meter per second. So u is the initial velocity and a is the acceleration, that is in meter per second square. So find the acceleration of the body if traveled 168 meter in 6 seconds with an initial velocity of 10 meters per second. So what is the initial velocity is given? It is given as 10 meter per second. And then what is the rest given? The value of S is already given as 168 meters. And time is also given as 6 seconds. So what was the equation? S is equal to ut plus half at square. So already just substitute the values and find the value of a from the equation. So 168 is already given, and value of u you already know, that is t into, then what it is, the value of 6 plus half into a into 6 square is 36. So you can cancel it and write it as 18. So 168 is equal to 60 plus 18a. And remember that when you have variables and integers on integer constants on equation, so try to make the integers on one side of the equation and variables on other side of the equation. Also, when you move a variable from one side of the equation or an integer constant from one side of the equation, what you have to remember? You have to always have a change of sign. So similarly, so when I move this integer constants to this side, I'm going to change here. So 18a. So what it is? It is 108 is equal to 18. So what is the value of a over here? So 18a. So value of a is nothing but 108 by 18, which is 6. So what is the acceleration when the body was traveling in 168 meters in 6 seconds? So with the initial velocity 10 meter per second square, then the acceleration was 6 meter per second square. So that's how you find the answer. Now let's do the final problem. So when three resistors in an electrical circuit, 1 by RT is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula for finding when resistors are connected in parallel. So find the total resistance when R1 is equal to 5 ohm, R2 is equal to 10 ohm and R3 is equal to 30 ohm. So everything is given. So from the final equation, you just have to find the total resistance. So 1 by RT is equal to, what is the value of R1 given over here? 5, right? And what is the value of R2? 10. And what is the value here? 30. So to do calculations when you have different denominators, so what is the first step? When I have already taken in my lecture on fractions. So when you have these kind, to add these fractions together, first you have to take the step is to make the denominators of the same value. So to make the denominators of the same value, what you do? You do take the LCM. So let's find the LCM of all these numbers. What is LCM? LCM is the least common multiple, right? So from this 5 itself I'm going to take first, because 5 is already divisible in all these numbers. So 1, 2 and 6. Again 2 is here, so 1 and 3. So 3. So we know that LCM for this solution is 5 into 2 into 3. So that is 30. So 30 is the LCM. So to take the LCM, what you have to do here? Multiply here with 6. And also remember that when you divide a fraction with in the denominator with 6, always do it in the numerator too. So don't forget these steps. Okay. And next here 10 into 3, here into 1 into 1. So what it would be? 6 plus 3 plus 1 by 30. That is what? 10 by 30. So now we know that 1 by RT is equal to 1 by 3. Right? Because 10 by 30 is nothing but I did cancelling because both are divisible by 10. 30 is 3 times divisible by 10. So I wrote it as 1 by 3. And what is this? Now you have to take the reciprocal. Reciprocal means what? You write the numerator on the denominator and denominator on the numerator. So when you do it on the both sides. So I'm going to take the reciprocal of the equation. So what it becomes? RT by 1 is equal to 3 by 1, which is nothing but RT is equal to 3. So the total resistance is 3 ohm. So with this, I come to an end of this lecture on simple equations, and on my next lecture, I will be dealing more on simple equations and then also on simultaneous equations. So what are simultaneous equations? Simultaneous equations are, there are two unknown values, and from this there are two equations given, and from this we have to find the values of both these unknowns. So this I will be covering up on the next lecture. And also if you like my videos, please like, share and subscribe. So that's all for today, and see you on my next lecture. Bye bye.